Welcome everyone to section 4, and we are going to be exploring your hominin ancestors. And in order to do that, we've got to do some comparative anatomy. And so we're going to take a look at some of our friends here on the table. And I can introduce you here to an anatomically modern Homo sapien, which is you. And remember early on when we first started this lab, I said you needed to look for the big three. And so you need to assess the brain size or the crania size. You need to assess the dentition. And then you also need to assess whether or not this skull had bipedal locomotion, and I'm going to show you guys how to do that. And when you're doing comparative anatomy, even if you don't have a little fancy little human skull available or in your back pocket, just look at yourself, right? How does your brow ridge feel to you? You know, how are your eyes positioned in your head? You can look at your own anatomy. It comes in really handy when you're assessing other hominin ancestors for comparative purposes. And so let's examine the big three on you, right? And so here we have an anatomically modern Homo sapien. And if we start out with the brain size, if we turn this sideways, when we're assessing brain size, we're actually looking at the amount of material that kind of fits inside this cranial area, and it's called cranial capacity. And so the way often scientists will measure that is they will fill in this area. There's a convenient little hole there. I'll talk about that hole in a second. They'll fill in this area and they'll measure the weight of the material that's in there to get that cubic centimeter measurement. And so you will be looking at cc's for all of your hominin ancestors and comparing that and the relative amount of cc's to tell how closely related all these specimens are to you. All right, so that's the brain size. That's one of the big three. The second of the big three is dentition. Okay, so if we kind of pull the jaw open here, there's a number of things that paleoanthropologists look at, but one of the first things they look at is they look at something called a dental arcade, and that's the shape of your teeth in the row. And so if you look closely at this dental arcade, the shape is a parabola. It's not necessarily a U shape, and a parabola means that beyond the U, the edges of the U's are flared out, right? So if I hold this guy down, you can see it's not a U shape would mean the dental arcade would be squished in a little bit more. And this guy's dental arcade, which is U, is kind of flared out on the side. That's a parabolic shape right there. All right, so big brain, parabola for the dental arcade. Also look at the shape of the teeth. And so the shape of the teeth can tell you a lot about what an organism eats here. And so you don't see some big canines on here. The canines are reduced a little bit. And there's also a lot of general dentition, which means we eat a lot of different things. It kind of indicates that we're omnivores, which is one of my favorite things about being a Homo sapien. All right, so big brain size, dentition. And so now what you're thinking to yourself is, how in the world can I figure out if this is a bipedal organism if I don't have any postcrania? I don't have any femur, I don't have any pelvic girdle. There's a way you can do it. And so this hole right here in the crania is called a foramen magnum. And what goes into the foramen magnum is your spinal column. And so in organisms that are bipedal, this foramen magnum has to be pushed forward, right, more anteriorly to accommodate you being bipedal. If the ancestral condition is to have the foramen magnum here, if the foramen magnum didn't move forward to allow you like this, you'd be walking around with your head down like that, and that would be really inconvenient to kind of walk around with your head down. So let's take a look at one of our closest relatives. And we often do comparative anatomy with our closest primate relatives because it kind of informs us as to ancestral traits. Big brain, reduced dentition, and bipediality are what we call derived traits. This guy has all the ancestral traits. So if you compare the brain size, I don't even really have to put this side by side with the Homo sapien. You can already see that there's a big reduction in brain size for our chimpanzee friend. If we look at the dentition, what you'll notice is it's a beautiful U shape. It's not parabolic, right? It's not a parabola. And then if you look at the foramen magnum on the back of the skull, in the human, it's here, right? And this guy, it's pushed back. And that will allow this organism to go around on 2 feet and have its head in the correct position when it's moving around the landscape. So ancestral conditions, derived conditions, and welcome to your first species. So here is the first species that you have to assess to see how closely related it is to you. And I'm going to give you guys a hint. This species right here is one of the first hominin fossils found with tools or evidence of tools. And if you look at the cranium material here, you can see here, you're going to look at the brain size. And again, you want to think about your own head, right? So you're going to be looking at the size of the brain here. The next thing of the big three that you want to look for is you want to look at the dentition. And so if we look at the dentition here, you'll notice that the fossil is not complete, but you can still get a sense of whether it's a true U-shape or whether it's a parabola. And then last but not least, it's a little bit difficult to see. This is the area where the foramen magnum is. And so again, you want to compare that to yourself and look at the ancestral trait for the chimpanzee. And you will be able to kind of assess how close it is between these two of our relatives, our friends that we have here. All right, so remember, the hints is what's going to really help you find out what this species is. It's one of the first hominin species that are found with tools, and so you need to kind of look that up in your textbook. You can probably easily Google that as well. And remember, you need to fill in all the information in the lab, and so in addition to finding out that the brain is a little bit bigger, you need to go to the site where it will tell you exactly how big the brain size is in order to complete the lab on this. And I've given you two websites, one for the Smithsonian Institution and one for eFossils. And you're going to love those sites because as soon as you click on them and give them the hint, they're going to be able to kind of help you identify that species and get the details that you need in order to compare this hominin to you and the other hominins that are in this lab. Again, it is comparative anatomy. So I hope you guys have a little bit of fun with this. And now we're going to move on to your next hominin relative.